So remember, we want to get the distance between the center, which is 1, 3, and the point 5, 7, which is on the circle, right? So going back to our distance formula, okay, right? And this is here just saying what I said in words before, that, you know, to get the radius, we need the distance from 1, 3, the center, to the point 5, 7, which is the same as the length of this line segment, the radius. Okay. And how do we do that? That's what this formula comes in, our distance formula. Right? So again, remember what you do. You subtract the x coordinates, square the difference. Subtract the y coordinates, right? Square the difference. Add. Right? Each time I think you get -4 squared, right? Yeah. Which is 16 plus 16, so you get the square root of 32. So yes, you get the square root of 32. So an equation for the circle here, you know, for this circle, okay, we have the center, that should be HK, not AB. I don't know why I have AB there. That should be HK, which is 1, 3, okay? So we have HK here, as you can see, which is 1, 3, right? That's our center. So just like before, H would be 1, K would be 3, and the radius is the square root of 32. And when you square a square root, right, what happens? Well, the square root symbol essentially goes away. You know, we saw that, I think it was in section P6. So what we end up with is this. So let me say that again, right? So the center is 1, 3, okay? So even before calculating the radius, we have HK equals 1, 3. We would know H would be 1, K would be 3. So you would have x minus 1 squared, right? The x coordinate of the center, plus y minus 3, the y coordinate of the center, that's squared. We calculate the radius to be the square root of 32. And again, when you square the square root, that square root symbol is gone. We're left with this. So that's our circle. Okay, that's it for that. All right, that's good. Are there any questions about that? Because if not, I'll start the next section, which is on lines. Okay. So let me do that then. All right, so here, what I'm going to go through, okay, I'm going to go through lines now. Okay, so let me just do that. All right, so this is what 2.3 is. Now, so basically in this section, I'm going to present to you what the definition of the slope of a line is. Okay, I mean, really to understand, I mean, we do know that if you connect any two points together, if you have any two different points, you know, in the Cartesian plane, you can easily connect them by a straight line, or a straight line segment, I guess, if that makes more sense. But to really understand lines, as you'll see, we really need to have this concept of slope. We really need the concept of slope. So we're going to see that. We're also going to see different ways of writing the equation of a line. You know, lines are graphs of equations, and that equation can be written in different ways. Let me say that again. Lines are graphs of equations, basically equations in the variables x and y, but x and y each only have one to the power of 1. You'll see what I mean, though. But you can write that equation in point-slope form, or you can write it in the slope-intercept form. Point-slope formula and slope-intercept formula, in other words. And that's what I'm going to go through, not today, but this. The slope-intercept formula you probably have seen before. That's my experience teaching this course. Most students know that already. That's y equals mx plus b. Point-slope formula is a little bit more general. It's more convenient, though. At least I think it is. So as I said already, we really need to understand slope if we want to understand lines. Okay, so let's do that. So here is the definition of what a slope is. Notice that the slope of a non-vertical line is defined. Non-vertical line we have, right? So you take 2 points P and Q, any 2 points on that line, any 2 different points on the line. So in particular, where's the mouse? There it goes. Sorry, I couldn't find it. So any 2 different points on the line, since they're different, their x coordinates will be different, okay? Then the slope is just change in y. It's just the difference, change in y over change in x. That is, you subtract the y coordinates from each other divided by corresponding difference in x coordinates. Now, unfortunately, here you have to be careful with calculating slope because you're subtracting. So order does matter. I mean, I know there's this thing called rise over run people like to use. Personally, what I do is this. I like to have coordinates from the same point on top of each other. So for instance, if you look at Q, right? Q, you have the coordinates x2 and y2. Notice here in the slope formula, I have y2 over x2 directly. Both of them are in front of the minus signs, if that helps. And for P, x1, y1, I have y1 directly over x1. So again, slope, right? It's change in y over the corresponding change in x. You have to be careful, unfortunately, because you're subtracting. And this is only for a line that's not vertical. If a line is vertical, the slope is not defined. Okay, that's just, again, by definition. All right, so let's do an example or two. For instance, let's find the slope of a line that goes through these 2 points, 3, 7, and 5, 9. Again, I rewrote the slope formula here just for convenience. So let's do this. So we want to subtract the y coordinate, so I'm doing 9 minus 7, okay? Now for 5, right, 5 and 9 are coordinates for the same point. So I guess if you want, you can call it Q. We have 9 over 5, right? They're on top of each other. For 7, 3 is the other coordinate of that point. So 7 and 3 are on top of each other, as you can see. Right? Again, you could think of it as 9 minus 7 over 5 minus 3, corresponding change in x. And here you actually get 2 over 2, which is, of course, 1. So the line through the first pair of points has slope 1. For the second point here, for the second pair, okay, so what do? We have 3 minus 6, right? Again, corresponding change over negative 4 minus 1. Or again, if you want, 3 and negative 4, right? They're from the same point, so put them on top of each other. 6 and 1 come from the same point, they're on top of each other. And here you get negative 3 over negative 5, which of course is just 3 over 5. So those are just some easy examples that we're doing here. Now, slope can also have an interpretation that is slope is called the rate of change. Excuse me, it's called a rate of change. The idea is, we'll see this more later on, but I want to say it now. If you have a line and the slope, let's say, was m, if you were to increase your x, your input, your x that is, excuse me, by 1 unit, it turns out that the y value, your y variable, that's going to change by m units. Again, m is the slope. I mean, we'll see this more later on. Although I guess for this course, it's not too important, but it does come up if you take later math courses like calculus. But m is what we call it. The slope is what we call a rate of change. Again, if you increase x by 1 unit, right? What I'm trying to show you here is that your corresponding y values, that's gonna change by m units. So here it's going up, but it's gonna change by m units. That's the idea there. Okay. Are there any questions so far? Wait, hold on.